Hi everyone, and welcome to another video about polar graphs. Today we're going to talk about how to check the symmetry of a polar graph algebraically, and that means without having to graph it. So we have three kinds of symmetry. The first one is symmetry around the pole axis, the symmetry around theta equal to pi over 2, and symmetry around the pole. So let's talk about this in details before we go ahead and solve problems. So the first thing you got to know that the tests of symmetry in polar coordinates, you don't have to memorize how you do them, but you need to visualize them. The first thing you got to know is if you want to test for symmetry around the polar axis, or that one that looks like x-axis or the horizontal axis, this one, so the point has to be above or below the line, right? So the symmetry will have to be like up and down that axis. So if the point is above the line, so it's r and theta, so the point below the line will be the same r, because r doesn't change, and negative theta, because as you know, we measure theta counterclockwise. That's positive theta. If this is theta, then negative theta will be down there. So just what you need to do is replace theta with negative theta, and if the function keeps the same exact form, that means that you have symmetry around the polar axis. Symmetry around the line theta equal pi over 2, or in other words, the vertical axis or the y-axis. If the point is right here, r and theta, the point is r and theta, this point will be symmetrical around pi over 2 if it goes all the way there. And that means not only you have to change theta, r and negative theta becomes this point right here, and negative r as well for the point to translate to the other side. So in this case, to test the symmetry, you need to replace theta with negative theta and r with negative r. The last test that we have is symmetry with respect to the pole, or the origin point, or 0 and 0. If the point is r and theta, and it has to be symmetrical around this point, that means it has another image all the way here. And that's negative r and the same theta. The negative r and the same theta. So all you need to do is replace r with negative r. If an equivalent equation results, then the graph is symmetrical around the pole, or the origin point. And of course, we need to solve some examples to illustrate how this works. All right, so in the first question I have, test the graph of the polar equations below for the symmetry about x-axis and y-axis. They specified the question for x and y, but we're going to go ahead and do also about the origin. Just keep in mind that the graph on the right-hand side, I did it just for you to visualize it, but it's not going to be given in the question, because I told you in the beginning, we're going to do this algebraically. So we have three tests. Let's start by doing the first test, which is x-axis or the polar axis. So I'm going to say polar axis test. So that's the first one. So we're going to go ahead and replace theta with negative theta. That's the test. Okay. So it's going to go ahead like this. So r becomes r because I didn't change anything of r. It's going to be 1 minus sine negative theta. All right, so what's sine negative theta? Well, we do know that sine is an odd function. And odd functions, they're not going to get rid of this negative inside. So this negative inside is going to go all the way outside. So it's going to be r equals 1 plus, because negative negative, sine theta. And as you can see, this is not equal to the main function. So there is no symmetry around the polar axis, so no symmetry, no x-axis symmetry. Okay, so let's go ahead and do the y-axis, or the pi equal to, not pi, theta equal to pi over 2 line, or the y-axis. Okay, so it's going to go ahead and replace theta by negative theta and r by negative r. And if you do this, it's going to look like this. Minus r equals to 1 minus sine minus theta, again minus r equal to 1 plus sine theta. And if we divide or multiply the equation by -1, it's going to be r equal minus 1 plus, minus r minus sine theta, which is going to be r equal to minus 1 minus sine theta. So it's pretty much, it looks wrong. It looks that it's not really symmetrical around the y-axis. But I want to stop here and discuss here for a second. As you can see in the graph, it's absolutely symmetrical around the y-axis. The thing is, when you do one of those tests and the result is positive, that means it's conclusive, that means you can move on. However, if the result is negative, then you have to give it another try another test. And as we know that we have another test for line pi over 2, which is not just replace r and theta by minus r minus theta, because you know that the other test is keep the r positive and add pi to the theta. So let's try this one and let's see if it's going to be conclusive or not. So I'm going to replace r by r and theta by pi minus theta. It's going to be 1 minus sine pi minus theta. And r equals 1 minus, of course, sine pi minus theta. Pi minus theta is like the second quadrant, and that means it's the sine part. So sine pi minus theta is just theta. So it's going to be sine theta. So as you can see, it's exactly like the given problem. So that means it's actually symmetric around pi over 2, or symmetric around line theta equal pi over 2, or the y-axis. So we just keep this point in mind, and we're going to talk a little bit more about it in the future. If the answer is negative, that means that you have to try one more test. You didn't just stop there. All right? So let's move on to the next example. R equals to 1 plus 2 cosine theta. And we need to see what kind of symmetry do we have here. Okay? So we're just considering the x and the y-axis for now. So let's try the x-axis. The x-axis symmetry. I know that at the first test I need to replace theta by negative theta, and r I will just keep it. Okay? So it's going to be r equals to 1 plus 2 cosine minus theta. 2 cosine minus theta. And because cosine is an even function, that means cosine negative theta is just negative, it's just cosine theta. Then r equals to 1 plus 2 cosine theta. That means this graph is symmetrical around x-axis is true. And as you can see from the graph, it pretty much illustrates that it's going to be symmetrical around the x-axis. Alright, so let's take a look at the y-axis symmetry. Y-axis. The y-axis, as you know, the first test that we have is replacing theta by negative theta and r by minus r. So it's going to look something like this. Minus r equal to 1 plus 2 cosine minus theta. That means minus r equals to 1, and plus cosine minus theta is just cosine theta. As I said, it's an even function. It's going to be plus 2 cosine theta. So r equals to minus 1 minus 2 cosine theta. And of course, it's not really equal to the original equation. So we can say that it's not really symmetrical around y-axis. However, because the answer is negative, we have to give it one more try with another test. So the other test is theta is pi minus theta, and r is the same. Okay, so it's going to be r equals to 1 plus 2 cosine pi minus theta, and pi minus theta is the second quadrant, and it's not the quadrant for cosine, it's going to be negative. Then r equals to 1 negative 2 cosine theta, which is not really the original equation, so it's not symmetric around the y-axis. Not symmetric around y-axis. See, we did two tests, test 1, and test 2. Both of them failed. That means it's not going to be symmetrical around y-axis. And of course, it's pretty easy. We just use the graphing calculator. Just graph it. Make sure that you get this point right before submitting your answer. Next question, I have r equal 1 minus 3 sine theta. And from the graph, I know it's going to be symmetric around the y-axis, but we just need to make sure that this is actually true. Okay? So I'm going to start with the x-axis anyway. I know it's false, but I'm going to do it anyway. So x-axis, I know that I have to replace theta by minus theta, and I'm going to keep r. So r equals to 1 minus 3 sine minus theta. And as we know, r sine is an odd function, so it's going to be 1 plus 3 sine theta, not equal, and it's positive, then this one fail, not symmetric around x-axis. So let's go ahead and try the y-axis test. The y-axis, I know I replace r with minus r, theta is minus theta, so let's go ahead and test this one. It's going to be minus r equals to 1 minus 3 sine minus theta, so it's going to be minus r equal to, sine is an odd function, still it's going to be 1 plus 3 sine theta multiplied by negative 1, that's going to be minus 1 minus 3 sine theta, again negative, that means I have to try one more test, one more test. So I'm going to try keeping the r as it is, and theta becomes pi minus theta. Okay, so it's going to be r equals to 1 minus 3 sine pi minus theta. That means r equals to, sine is pi minus theta is the second quadrant, which is the sine quadrant, so it's going to be theta, so it's going to be 1 minus 3 sine theta, which is the original equation. That means it's actually going to be symmetrical around the y-axis, because it's the same equation as given, as you can see. Alright, let's see if we have one more example. It's the rose petal, and I know that this graph is actually not symmetrical around anything but the y-axis, because it's not symmetrical around the x-axis, otherwise there would be another petal right here. It's not symmetrical around the origin, because if it were, there would be another rose petal right here. So this pretty much is symmetrical around the y-axis if you use the graphing calculator. However, if you don't have one and you just want to use your algebra, it's pretty easy. What we're going to do is we are going to do the y-axis first, y-axis this time. It's fine. If you have a graphing calculator, it makes it easy for you to decide. I know I need to replace r with minus r, theta with minus theta. So it'll be minus r equals to 4 sine minus 3 theta. And we all know that sine is an odd function, so the negative would go outside, so it'll be minus 4 sine 3 theta divided by minus 1, or multiply by minus 1, so it'll be 4 sine 3 theta. We don't even have to do another test, because it looks exactly, it matches exactly the original equation. That means r equal 4 sine 3 theta is actually symmetrical around y-axis. And if you're not comfortable saying y-axis, just say theta equals to pi over 2. So just to sum up, before we end this video, I just would like to thank you very much for watching. Please leave me comments if you need any more help. But at the end of the day, just don't do one symmetry test unless you are completely sure that this is going to be okay. However, I recommend that you do more than one test. Use your graphing calculator to make sure that you reach the right decision, because sometimes algebraically does not actually show you the exact thing that you need to look for. So please go ahead, use all the tools that you have, and you're going to get the right answer at the end. Thank you very much again. You have a very good day.